Hello and good evening. I am Navindran. Today I will sing about our project 2 for the subject PSA. For my part, I will explaining about the introduction part and also the chi-square test. So let's move on to the introduction part. The title of our project is Survey on Heart Disease Prediction Among People. The purpose we choose this topic is we are eager to know about the classification and also statistical prediction about heart disease. Because nowadays the heart disease become more viral and important issue in most of the countries. We also got this information on dataset from Kaggle, which owned by Elena Venkata Sai AB. Then we collected more information about the classification for heart disease prediction. By this, we are able to do the data analysis such as correlation, regression, and set-square test by defining new variables. This data analysis helps us to achieve our purpose of this project.
Okay, my name is Kuganraj. Uh, I will explain about the data analysis. For my part, I will explain about the hypothesis testing by two sample and correlation analysis. Okay, for 3.1, first test is hypothesis testing by two sample. Okay, for hypothesis testing by two sample, we used maximum heart rate of the person with disease and without disease. So first we are assuming that the variance of the both variables are unknown and unequal. Then we should find the degree of freedom by using these two formulas here. Before that, we should write the hypothesis testing. The null hypothesis is mean 1 equal to mean 2. The alternative hypothesis is mean 1 bigger than mean 2. After that, for tested statistical value for this, we use this formula and calculated in R programming. We got 7.9531, and then we should calculate the degree of freedom, the V value. Okay, here we got it from R programming 269.9026. Okay, I round off it for 269. So our degree of freedom is 269. Then we also got the here t alpha means the critical value from the R programming. Here we got the negative 1.6505, so we make it positive, and from these values we can conclude and make decision. So here we can see test statistical value bigger than critical value. For example, here 7.9531 bigger than 1.6, so the decision is reject null hypothesis. The conclusion is there is no sufficient in evidence to conclude that mean of maximum heart rate of the people in disease and without disease is equal. There's no such sufficient evidence. That's all for the hypothesis testing by two sample. Then the second part is 3.2 is correlation analysis. For correlation analysis, we also get the graph uh, from the R studio. First of all, we should calculate the R value. R value here means that coefficient of correlation analysis. Okay, we got this from R programming. We got 0.2794. Okay, this show R value is a positive correlation between the age and blood pressure. Yes, for correlation we use the variable age and blood pressure while resting of the person. Okay, then the significant test for correlation, the null hypothesis is rho equal to 0. This means no linear correlation occurs. Then the alternative hypothesis is rho not equal to 0. Then we calculate the test statistical. We got it from the R programming. We got 5.0559. Then we can conclude it from the R value. So we got the critical region from the R studio. So here we make decision because the t value is bigger than critical region. So we reject the null hypothesis. The conclusion is there is insufficient evidence that there is no relationship between age of the person and blood pressure under the 0.05 significant level. So as we can see here, this is the graph that we get from the R studio between the age and blood pressure for correlation analysis. here the graph shows that the correlation is weak and almost straight, because here we got the R value is 0.2 or near to 0, so it almost no correlation occurs. So the graph shows that. That's all for my part. Thank you.
Okay, so now I'm going to explain about the regression and also the conclusion of this project. So firstly, about the regression. So first we need to find the estimated regression model, which is using this formula. This is the formula of the estimated regression model. So in the estimated regression model, we need to find the value of beta 1 and also beta naught. So this is the formula of beta 1 and also the formula of beta naught. So in the R studio, we have gotten the value of beta 1, which is negative 0.6077. And also we got the value of the beta naught as 182.6844. And then lastly, we just substitute the value of beta 1 and beta naught into the formula of the estimated regression model. Okay, so next up, we need to do the explained and unexplained variation. So in here, we need to find the value of SSE, SSR, and SST. So by using these formulas and all, and using the R studio, we got the value for the SSE, SSR, and SST here, stated here in the table here. And then, by using the value of SSR and SST we got from the previous one, we find the value of coefficient of determination R squared using the R studio again. And then using the R studio again, we find the value of standard error of estimate using the value of SSE. So in the R studio, we got the value of standard error of estimate here. And then next one, by using the value of standard error of estimate from the previous one from here, we will find the standard deviation of regression slope. So by using the R studio, we got the value for the standard deviation of the regression slope. And then finally, for the hypothesis testing, the H null is beta 1 is equal to 0, no linear relationship. And H1 is beta 1 is not equal to 0, linear relationship exists. So from the R studio, we get the value of t is equal to negative 4.3144. And then we find the t value from the table, and then we compare it with the t value we got from here. So since that we got the t value is bigger than the value of the t table, we reject H null because there is no sufficient evidence to conclude that the age of people will not affect the maximum heart rate of people at 95% confidence level. And then finally, for the regression part, this is the table of heart rate against age for the regression. This is the scatter plot. Okay.
So the next part I will move on to the chi-square test. So this is the data we collected from the data set. There are two variables, qualitative variables, which are sex in the upper part and target, which is on the left part. 0 in the upper part represents female, while 1 represents male. 0 in the left part represents they doesn't have disease, while 1 represents the F disease. For female who doesn't have disease is 24, while male who doesn't have disease is 114. The female who has disease is 72, while male who has disease is 93. So let's move on to the chi-square test. For the part 1, hypothesis statement, the null hypothesis is there is no relationship between the variables, while the alternative hypothesis is variables have a relationship. For the part 2, we will find the critical value. The confidence level is 0.05 and the degree of freedom is 1, because when we use the formula n minus 1 times n minus 1, we can get the answer 1. For the critical value chi-square, we will use the chi-square table to find the critical value, and you use the alpha 0.05 and the degree of freedom 1, we can get the chi-square from the table, the value 3.8415. So next we will find the test statistics value. First we will calculate the expected count before we calculate the test statistics value. The expected count for female who doesn't have disease is 43.7228, which we multiply 138 with 96 divided by the total sample, and the expected count for male who doesn't have disease is 94.2772. For the female who have disease is 52.2772, while the expected count for male who have disease is 112.7227. So next we will find the test statistics value. We will use the formula observed count minus expected count square divided by expected count. So 24 minus 43.7228 square divided by 43.7228, we can get the answer 8.8967. Next 114 minus 94.2772 square divided by 94.2772, we can get the answer 4.1260. Next 72 minus 52.2772 square divided by 52.2772, we can get the answer 7.4409. Next 93 minus 112.7227 square divided by 112.7227, we can get the answer 3.4508. When we add up all these answers, we can get the test statistic value chi-square, which is 23.9144. So this is our test statistic value. So this is part 3. So the final part is we state the decision. So the test statistic value is 23.914, which calculated from the using the table above, and then the critical value is 3.8415, which get from the chi-square table. So our test statistics value is exactly same when we use the R Studio. So this is the chi-square value, and the degree of freedom is 1. So since the test statistics value, which is 23.914, is greater than the critical value 3.8415, thus we reject the null hypothesis. The test statistics value falls within the critical region. So there is a then we can conclude that there is a evidence of relationship between the variables set and target. So that's all for my part. Thank you.
So as for the conclusions, so we have finished our analyzing the data for our dataset named Survey on Heart Disease Prediction Among People. So in the R programming, we also learned how to do the programming to get the scatter plot that I've shown you for the correlation analysis and also for the regression analysis. And from the scatter plot, we experience to find the coefficient of positive and or negative. So in the conclusion, the interesting part from three of us is that we enjoyed and learned a lot on how to do the R programming to get the graph for the correlation and regression analysis. So this is because the generating of the scatter plot is a new thing for us, as we just only started in R programming and we learned a lot on how to do the R programming. So finally we were able to finish this project with a lot of knowledges. And I think that's all from me. Thank you.